Hello, and thank you for watching this video on Network Foundations Understanding Junos, brought to you by INE. In this lesson, we're going to continue with our topic of user interfaces, understanding CLI modes and hierarchies. Now, in the previous lesson, we dealt with the CLI modes and how to move around the CLI. We learned about auto-completion and using Emacs style functions for working faster across the CLI. So this lesson, we're going to start talking about the configuration file dynamics and configuration modes. You ready? Let's begin. Okay, so I know there are a lot of elements in this device. Focus, however, in the two elements at the top. The small piece of paper that says active and the small piece of paper that says candidate. In any Junos device, there are always two configurations, an active configuration and a candidate configuration. The active configuration, it's what is currently saved and what is currently enforced at the operational level. Whatever your device has and it's running on, that is its active configuration. All right, it's whatever configuration you have committed in the past and now the device is using it. The candidate configuration is, for so to speak, a draft. Okay? Whenever you enter configuration mode in a Junos device, you're entering the candidate configuration. As opposed to other vendors, what you're doing here is not impacting the operation of the device in real time. What makes the difference is a single command which is called commit. When you commit, every single change that you have entered into the candidate configuration or the draft configuration now becomes operational, becomes active. Does that make any sense? So, let's just have a look at the graphic here. I have committed the candidate configuration, okay? Now, what's going to happen is the candidate configuration is no longer a candidate configuration, it becomes an active configuration. What used to be the active configuration, now it becomes the rollback number 1 configuration. Now, what is a rollback? Well, just as it sounds, it's a configuration which is available for you to roll back if anything goes wrong with the one you just committed. Okay? What this means is the Juniper device will store a copy of the old configuration in case you need it back. You can always restore to the previous configuration. And not only to one previous configuration, but to 50 of them. Okay? By default, a Junos device will store 50 configuration files. Okay? Or 49, because the rollback 0 is the active one, right? And as you can see there, active 0, that means it's rollback 0. So whenever you're editing, if you need to just remove your changes, you just do a rollback 0, and then it becomes the active configuration you're currently running. Now the rollback 1 that you have just created will replace the previous rollback 1 that was there, and the previous rollback 1 becomes the rollback 2. That rollback 2 configuration will be pushed and will push the previous rollback 49 and will drop rollback 49 into the garbage bin, the virtual garbage bin or virtual trash bin. Okay? That number 49 configurations which was stored, the oldest configuration, will now be erased from the system, and the one that was previously rollback 48 now will become rollback 49. The one that was previously rollback 47 will now become rollback 48, and so on. Okay, so just to make sure that I reinforce the concept of batch commit or batch configuration changes, I'm putting this other graphic here which focuses more on active and candidate configuration. So let's say in the candidate configuration, remember, which is a draft, you remove E, G, and L, just thinking that those letters mean actual changes in the configuration. Now you add X, Y, and Z, okay? This is in the candidate configuration. It's not active. It is not active. So once you decide to commit, this candidate configuration will become the active configuration. But remember, any individual change means nothing until you commit. This allows you the possibility of working in a lot of changes and reviewing a lot of different changes at the same time without the need of affecting user traffic, without the need of breaking anything, because until you hit commit, it'll become the active configuration. Now, there are different configuration modes, and this is a follow-up topic today to the previous one. The default configuration mode is the one in which users can commit the same configuration file using different sessions. What does it mean? It means Peter is modifying the Juniper device configuration, I don't know, via console. And then John is telnetting or is doing an SSH session remotely to the device, and he's now also editing the configuration file. Now, they are both making changes to the candidate configuration. If any of them, if they are not talking to each other, if they don't know that the other is currently working on it, and they are not talking to each other, and one of them commits, the changes that both of them made will be committed. Okay? Even if those changes were not intended to hit in immediately or whatever, they will both be committed, and you may have unpredictable issues because it's different people configuring different things, not talking to each other. This will happen if you're using configuration in just the default mode. Fortunately, we have solutions for this. One of them is the private configuration. When you're using private configuration, each user actually owns a private candidate configuration. When they commit that, only their changes will be saved. Only their changes will be pushed to the operational status of the device. So with the same example, Peter is working on his own private configuration, and John is working on his own private configuration. John is adding new interfaces. Peter is simply modifying a parameter of the VPN. When Peter commits, only the modified VPN parameter will become operational. The interfaces that are being added by John are not committed until John commits his own private copy of the candidate configuration. So private configuration is great for these environments in which multiple users will be making changes to the device. And finally, we have also the possibility of exclusive configuration. This is what in other systems is called acquiring a lock. Okay, so pretty much if I'm logged in and I'm configuring in exclusive configuration mode, I'm locking everyone else out of the device. I'm not allowing anyone else, not even in private mode, I'm not allowing anyone else to configure anything on this device until I'm done and I exit configure exclusive mode. Okay? This is important if maybe you're a super user and you're the one making the final decisions, and you simply don't want anyone to bother while you're doing something really important on the device, and you're just excluding them. Okay? Well, great. So those are configuration modes. So configuration in a Juniper device exists within different hierarchies. The first hierarchy is the edit hierarchy. As you can see above the prompt, there's always a name of the current hierarchy where you're at. If I wanted to edit something in an interface, for example, I could do it from the edit hierarchy just using a set command. So say, for example, I want to add an IP address to an interface. I can do this. Set interfaces Giga Ethernet 002 unit 0 family inet address 10.10.10.8/30. Let's be more accurate. .9/30. Okay? This is a way of configuring it just by doing a full set command with all the sub-hierarchies concatenated from the root hierarchy, which is edit. There is another way we can do this. I could do edit interfaces. Do you see something changing? Now the prompt is now edit interfaces. So I am within a sub-hierarchy, which is interfaces. If I wanted to edit Giga Ethernet 002, I could do edit Giga Ethernet 002. And now what do I have? Edit interface Giga Ethernet 002. The commands that I have now are limited to this hierarchy. As you can see, I can, for example, configure link mode. I can configure gratuitous ARP options. I can configure a description for the interface. I can, configure the MTU for the interface. I can configure the interface in promiscuous mode. I can configure speed for the interface, etc. Unit, VLAN tagging. So these options that I have with the set command now are specific to the interface Giga Ethernet 002. Okay? I can even go further. Edit unit 0. Now I am in interfaces Giga Ethernet 002 unit 0. Each time you do edit is similar to a cd command if you would compare it to a Unix environment. What is cd? Change directory. So it's similar to you browsing a directory or different hierarchies within a directory, for so to speak. Okay, but this is configuration. So people choose different things. Me, I will normally work it all from the root hierarchy, which is edit, unless for some specific reason I need to kind of just see smaller configuration snippets, for example. So I would use the edit to get into a hierarchy. But these are different ways you can work on it. Now, if you wanted to navigate hierarchies, you can do so with the top up or exit option. So if I wanted to be in just Giga Ethernet 002 hierarchy, I can do up, and now I am at the Giga Ethernet 002 hierarchy. If I wanted to go back to configure unit 0, no problem. Edit unit 0, I'm back in the hierarchy. Now, if I want to go 2 levels up instead of just 1, I can do up and then the number 2, and it takes me 2 levels up on the hierarchy to where interfaces is. Make sense? If I wanted to go back, edit Giga Ethernet 002 unit 0, I'm back to where I was. If I want to fully exit this hierarchy, I can just do top, and it'll take me back to the top hierarchy, which is edit. Does that make sense? Now, let's see, for example, how these hierarchies work in the sense that, or in the context of a show command. So show interfaces. Okay, well, there's going to be a lot of output. but the first part of the output shows me fast Ethernet 000. Okay? Fast Ethernet 000 has unit 0, which is configured for family INET, which is the interface family that will support IP addresses. And then it has an address of 20.10.10.2/30. Okay? Now, what's up with these brackets? Well, those brackets are key to understand how the configuration is organized and how the hierarchies and sub-hierarchies are displayed in a configuration file. I'm actually capturing now my my commands pretty much, or in the output that they will provide, and I am located again in the edit hierarchy, which is the root of the tree. Okay, so what I'm going to do show pipe no more. I'll show you pipes later. This will make sure that the device pretty much throws all of the configuration without stopping, without any paging. So we'll have a look at the current configuration for this device. Now I opened the text pad here, okay, and I'm going to be able to see the entire configuration. Okay, as you can see, then it starts with the system hierarchy, okay, and then the system hierarchy has the root authentication hierarchy, and then the root authentication hierarchy has the possibility of encrypted password. Okay? Now, within the system hierarchy, there is also name server, which is for DNS. There is also services, in which I'm allowing SSH, Telnet, and DHCP to the device. And then DHCP has another sub-hierarchy, which is pool, and pool has another sub-hierarchy, which is address range. Okay? And this is why in some parts of the configuration, you see a bracket like this, another one like this, another one like this, all together. Well, why are they all together? Because they are closing brackets for a lot of different open brackets that were there as part of this system hierarchy. So if you notice, after the system hierarchy, we have interfaces hierarchy. And this interfaces hierarchy also branches out from the main edit hierarchy, not from system. This is the reason why it has no bracket open before it, just a system. Okay? And this is also why everything under system has to close before the interfaces hierarchy begins. So see, for example, system bracket opens right here. Okay? Well, it closes right here. Root authentication opens right here. And since it doesn't have any sub-hierarchies, it closes right after the parameter, which is this encrypted password. Name server has just another not sub-hierarchy, another couple of parameters, which are the DNS servers, so it closes here immediately. But services, for example, services has DHCP, which has another set of sub-hierarchies behind it. So it doesn't close immediately, it remains open. Then DHCP has pool, okay? And pool is having other parameters inside of it. So for example, pool opens up router as well. Router closes right here. Pool closes right here. This other DHCP pool, it opens here, it closes here. This other router hierarchy, it opens here, and it closes here. Okay? Then services, it never closed, so it has to close sorry, DHCP never closed. It has to close at a certain point. So here it is, DHCP, and it closes right here. Services also needs to close. It closes right here. System needs to close before interface kicks in. It closes right here. Now, there are actual text editors for programming. which will allow you to select a particular bracket and it'll show you exactly where it closes. One of such is called Notepad++. This is for Windows. That's the reason why I'm not using it here. Okay? But you will find it very useful because you point at one bracket, it tells you exactly where it closes. Okay? Having said that, you're not going to have such text editor for the exam. So it's going to be a good thing that you start as we move on, right? Because right now we're just starting, but as we move on with the rest of this series, that you start getting used to displaying your configuration or just configuration snippets and start finding where a particular bracket opens and where it closes. Does that make sense? You need to find it because you're going to see trick questions which are related to bracket open and closure.